Okay, so we want to take a look here at why similar triangles and dilations are related to slope. So I'm going to make a unit triangle here. And this is 2 to 1. So we've studied slope quite a bit. You know this means that rise over run equals 2 over 1, which is just 2. Now I want to talk about how you can derive an equation for this line using similar triangles and dilations. So what if we dilate this triangle, and then we get a different color, with a scale factor of 2? What would that new triangle look like? It would be 4 to 2. That has the same rate of change. The thing is, the side lengths of these triangles are proportional because you have similar triangles that are dilated. So you could say 4 to 2 equals 2 to 1. And 4 to 2 reduces to 2 over 1. So this is true, and we know this because, like I said, the triangles are similar, they have been dilated. One is the image of the other. Well, what if we want to define every single point of the line? Now, what I did so far is I defined this point here, this point here, this point here. So we have 3 points on the line so far. We have from 0, 0, we have up 2, right 1, and then we also have from 0, 0, up 4, right 2. That defines 2 points. If we want to define every point on this line, we would have to use the generic point x, y. So there'd be another triangle in here for a random point here, and then down. We would have y for the rise, x for the run. So here's your random point x, y. But we know the ratio of x to y, because it's on this line, is the same as 1/2. And the reason we know that is because for a linear equation, that's what makes a linear situation. So we know this ratio of y to x has to equal 2 to 1. For any point on this line, the rise to run ratio has to be 2 to 1, because that's what we have. We have a 2 to 1 ratio. How do you turn this into a linear equation? You cross multiply to solve the proportion. Y times 1 equals y. X times 2 is 2x. So y equals 2x is the equation of this line, and you can see the equation, how it was developed based on these similar triangles. So this means any point on this line, no matter where you pick, is going to create a similar right triangle with a rise to run ratio of 2. Now let's take a minute and look at the generic situation. Here's a graph, xy, and I'm going to create a line. It goes right through the origin. Now we don't know what the rate of change is, but we know there is a rate of change. I'm going to make a unitized triangle that goes up m and right 1. So this is the unitized triangle. The rise is m, the run is 1. Now I'm going to make a second triangle. Just to a random point here. So here's your triangle to a random point, and y is the rise, x is the run, and we're going to use, it's a dilation. Now this xy triangle is a dilation from the original unitized triangle, so it is similar. And that means the sides are proportional. So I'm going to write a proportion based on these two triangles. I'm going to say, right over here, m to 1 equals y to x. I'm just creating, based on these similar triangles, a proportion. So to turn this from a proportion to an equation, I'm just going to cross multiply. And 1 times y is y, m times x equals mx. So there is your equation for a proportion situation. and it's based on these two similar triangles here and the dilation that created them. So any point that's on this line with rate of change or slope m is going to be in this pattern y equals m times x.